Hi, this is episode 74 of Crondos. I'm your host, Jordan Hudgens. I'm a Ruby dev and the CTO of the DevCamp platform. First and foremost, I want to say that the title of this post, Load Balancing versus High Availability, is a bit of a misnomer. However, I wanted to cover it because it's a topic discussed in many job interviews. If you're interviewing for a coding job, there's a good chance that your understanding of scalability will come into question. Therefore, you should have a solid understanding of load balancing and high availability. In order to understand the concept and the differences between the two, it'd help to first walk through what they each represent. First is load balancing, which is a process of spreading a system over multiple machines. This process typically has a goal of making a system more scalable by leveraging more than a single server. Next, high availability is more of a feature than a process. Essentially, high availability means that if one of a system's components go down, it won't bring the entire system down with it. As shown in this diagram, a load balancer is actually a piece of hardware that works like a traffic cop for requests. This allows a system to not force 100% of an application's load on a single machine. For example, can you imagine what would happen if you tried to send all of Facebook's billion-plus users to a single server? It would crash in a second. The limits of a single server are quite small when it comes to the number of requests that it can simultaneously manage, which is where load balancing comes in. A well-configured load balancer can spread billions of requests across a full farm of servers. This is a process that you'll need to become familiar with if you're wanting to work with a highly trafficked application. Now let's take a deeper dive into high availability. In this diagram, you can see how high availability operates. Since a system being highly available is more of a description than a tool, there are countless ways that you could map this out. However, the key to remember when it comes to high availability is redundancy. A highly available system has the ability to instantly redirect requests to a backup system if a component fails. Usually, this process is accomplished by the following type of workflow. Server A has a cloned server B. Server B is offline but constantly monitors server A. As soon as server A goes down, server B switches on and all traffic is redirected to server B, and the end user doesn't even know that server A even went down. In this scenario, the official term for server B is called a hot spare. In review, there are two important distinctions between load balancing and highly available systems. First, load balancing is connected to an actual piece of hardware, namely the load balancer, whereas being highly available can be achieved via a number of different processes, some of which can even include a load balancer. So you can combine both components, and if you're doing this for a job interview, that's a really important thing to understand. But second, and very important, is that a system can have a load balancer and still not be highly available. If a system is configured to simply route traffic to various servers to decrease the load of any single machine, that does not mean that it's highly available. For example, if you have a load balancing kind of architecture, it may mean that it's scalable, but it doesn't mean that it's always going to be online. Because what happens if you set up a load balancer, but you don't have any kind of redundancy for the load balancer itself? When requests come in, instead of it being able to be routed to different servers, it just is down and the site's not available, which means that it doesn't have high availability. You could implement a highly available system with a load balancer by being able to have a redundant load balancer and have that system monitoring it. And when you get into really complex architecture and those kind of things, then you'll take a deeper dive into that. But it is a really important distinction to know. Just because you have one side of that equation doesn't mean that you have the second side. I hope that this has been a helpful discussion on how to answer the coding interview question regarding load balancing versus high availability, and good luck with the coding interview.